Okay, so as we continue in section 2.1 about some graphs of numerical data, we're going to talk about the stem and leaf plot. This is probably the least used of all the different types of graphs. Okay, so the idea behind a stem and leaf plot is you put the beginning of the numbers here, and these are called the stems, and the end of the numbers are called the leaves. So in this stem and leaf plot that I have, this 1 actually represents the tenths place of the number, and the 4 is the ones place. So this would mean this I have the number 14. And these are different class sizes, so there was some class that had 14. The largest class then had 51. I have a whole big string of zeros here on the 4, so that means that's 5 classes, because there's 5 zeros that have size of class 40. So that's the idea behind how a stem and leaf plot work. Okay, in order to make one, okay, you first have to decide which part of the number is going to be your leaf and what values do you need for the stems. Okay, so here in this is the percent of residents age 65 and older in each of the states as of July 2008. So the first thing to do is you would just find the smallest value, which Alaska's at 7.3. Okay, so Alaska has the least percent of their population that's age 65 or older. Okay, and then you also will need to find the largest one, which if I look through my list, it looks like, how come I can't, maybe this, you'd think Florida or someplace like that, right? Here's Florida, 17.4. Is there any larger than this 17.4? Okay, so we need our stems to go from 7 to 17, and the values for the leaves, like on this one, will be 3, and then we'll have to denote that the decimal point is at the break between the 7 and the 3. Okay, so first we're going to write the stems in increasing order in a vertical column and then draw a line to the right of these values. So that's this part here. So remember, my stems went from 7 to 17, so I write all of the numbers. Even if I end up with some stem that doesn't even have a leaf to go on it, I still have to write that number. Okay, then we're going to add a leaf for each observation next to the corresponding stem. So here's that 7.3. There were no one in the 8%, but I still have the 8 in my stem and leaf plot. So just for an example, let me go back to this slide, right? And if we just look at Ohio, okay, Ohio's at 13.7. So we should see a 7 on the 13 stem. Okay, so here's the 13 stem, and there's one 7. There's somebody else that has a 7. Okay, so each of these stems represents the tenths place of the percent. Okay, and then the last step is it's easiest if you arrange them in order. Okay, so you can actually see Alaska here as an outlier at 7.3% of their population being 65 or over, and Florida is an outlier on the other end at 17.4%. And down here, you notice I said decimal point is at the line. That's just so I know that it's 7.3, okay, and 9.0%, and etc. all the way down through. Okay, so for another example, this is the percent of residents under the age of 18 in the 50 states during July of 2008. Okay, so you do the same idea. You got to find the smallest one, and then we also have to find the largest one in order to order our stems. So let's switch over here to StatCrunch, and I'm just going to have StatCrunch do this for us. Okay, so if I go to Graph and choose Stem and Leaf Plot. Okay, and now we're working with percent under 18. Okay, and again for now I'm just going to leave the rest of this okay, and we're going to hit Compute. And if you look at my stem and leaf plot, it doesn't look very good. One thing you might notice is I actually have the 2 listed twice here as a stem. Okay, so what you can do is if you have a whole bunch of leaves that would all go on the same stem, we can actually split the stem. So in this case I split it so that any leaf that's between 0 and 4 would go on the first 2, and leaves that are between 5 and 9 will go on the second stem. Okay, but this still is not a very good stem and leaf plot. Here it says the decimal point is 1 digit to the right of the colon. Okay, so this actually means that this 2 represents 21%. Okay, now if you look over here at my numbers, they're actually in tenths of a percent. So if I go back to options and edit this, I can make my leaf unit be by 0.1s instead of just by the wholest percent. Right now that's just rounding everything to the nearest percent. Okay, so if I change my leaf option to 0.1, and now compute, I end up with a much better stem and leaf plot. Now you notice each stem is still listed twice. Again, it's the same idea. The 0 through 4 stems go on the first, the 0 through 4 leaves go on the first stem, and then 5, 6, 7, 8, and 9 leaves go on the second stem. 20 is only listed once because there's no need to list it the first time because it would be the smallest value and it would have nothing on it. Even though I don't have any leaves on this 26, I still need to list it because there's numbers both above and below it. Okay, so now you can see here this 31.1 is definitely an outlier in terms of the data. I don't remember which state that is, but there's some state that has quite a few percent under 18. So if you look through this list, you should see the 31.1 down here at the bottom, and that's actually Utah. Okay, so a lot of times when you look at what the state is, you try to come up with maybe an explanation why Utah might have that large of a percent of residents under 18. The only thing I can think off the top of my head about Utah is the fact just that there's a lot of Mormons in Utah, so maybe they have larger families and they might have a larger percent that are under 18. That may not be the real reason, but just off the top of my head, that's what I was thinking. Okay, so that's the idea behind how stem and leaf plots work. If you still have too many, even when you list each stem twice, you can actually list it 5 times. And then the 0 and 1 leaves go on the first one, the 2 and 3 go on the second one, the 4 and 5 go on the third stem, the 6 and 7 would go on the fourth stem, and the 8 and 9 leaf would go on the fifth stem. Okay, you couldn't list it 3 times because then I can't easily divide the 10 leaves that I have into 3 equal parts, so that I'd have the same number of leaves that would go on each stem. Okay, the idea is the same as histograms, where you have to have each bar be the same width in a histogram. I have to have the same amount of leaves possible on each stem when I do this. Okay. And remember, if you're doing a stem plot, it's important to say where your decimal point is. So here my decimal point was at the colon. If you remember on the first one I said, it told me the decimal point is one place to the right of the colon. That's if I went back and did the default leaf, which if I just choose optional, I get the one we originally had. Okay, and here it says decimal point is 1 digit to the right of the colon. And that's how I knew it was 21 point. And then they rounded everything, so it'd be 21.0. Okay. So that's mostly our discussion for making graphs for numerical data. The next video we'll talk about summarizing what you see in the graphs when you look at a numerical distribution.